Students, today we are going to start with another important theory session from this unit known to be D and F block element. In previous theory session what we discussed, electronic configuration, oxidation properties, then colored properties, catalytic properties, magnetic properties, reducing properties, tendency to form complexes, tendency to form interstitial compounds, and in this session we are going to discuss three important points, that is, depending upon last session discussion, how to identify colored and colorless species. After that, important hint for MCQ, how to calculate magnetic moment of the species, and last one, steps involved in preparation of chromium compound, that is preparation of potassium dichromate. So these 3 points we are going to discuss in today's session. Let us start with the first important point regarding MCQ. What are the different cations given in front of you? To identify colored and colorless species. Which is colored, which is colorless. So once again I am going to repeat that condition. Colored species should have at least one unpaired electron. What about reverse condition? Colorless species, they do not have unpaired electron, or all the electrons are in which condition? Paired. So just you have to remember this important condition for MCQ, and by applying this in, you can easily judge whether given species is colored or colorless. Let us start one by one. What is first one? Cobalt plus 3 ion. Can you tell me, in case of cobalt plus 3, what happen if we are going to write here? Cobalt plus 3. Tell me configuration for cobalt. Argon 18, 4s2, 3d7. Atomic number of cobalt is 27. Now tell me charge. Cobalt plus 3. So there should be loss of 3 electron. What you are getting? 2 electron from 4s, 1 electron from 3d will be lost. What remain? 3d6. Now in case of d orbital, tell me 1, 2, 3, 4, 5 and 6. What it indicate? There is presence of unpaired electron. So it is found to be colored. Remember, this is found to be colored. Now, V plus 3 ion, vanadium plus 3. So, what is atomic number? Scandium 21, titanium 22, vanadium 23. So, what it become? Argon 18, 4s2, 3d3. Now, in order to form vanadium plus 3, there should be loss of 3 electron. So, 2 from 4s, 1 from 3d. What you are getting? 3d2. What 3d2 indicate? Presence of how many unpaired electron? 2 unpaired electron. So due to presence of unpaired electron, again it is found to be colored. Check next one. Copper plus 2 ion, Cu plus 2 ion. Tell me configuration. Not 4s2, 4s1. Argon 18, 4s1. So it become 3d10. What is charge here? Plus 2. So there should be loss of equal electron. 1 from 4s, 1 from 3d. So what remain here? 3d9. Now arrange these electron in 3d orbital. 1, 2, 3, 4, 5, 6, 7, 8 and 9. What is there? Presence of unpaired electron. It is found to be colored. What about next one? Ti plus 2. What about Ti plus 2? 22. So it become Argon 18, 4s2, 3d2. Ti plus 2 accompanied by loss of 2 electron from 4s. So what it become? 3d2, and 3d2 indicate what type of electron? Unpaired electron, and due to presence of unpaired, it is found to be colored. What about Mn plus 2 ion? That is Mn plus 4. So directly I am going to write here, Mn gives rise to Mn plus 4, loss of 4 electron. Tell me 4s2, 3d5. So 2 electron from 4s, 2 from 3d. So what it become? 3d3. So there is presence of which electron? Unpaired electron. It is again found to be colored. Remember this one. This is also colored. Now nickel plus 2 is also found to be colored. Remember 4s to 3d8. What about Zn plus 2? Can you tell me? Zn plus 2. Tell me configuration. Argon 18, 4s2, 3d10. In order to form Zn plus 2, there is loss of 2 electron from 4s. So what remain? 3d10. So how to arrange 3d10? 1, 2, 3, 4, 5. Again 6, 7, 8, 9 and 10. So all electrons in which condition? Paired. Means unpaired electron is absent and it is found to be colorless. Remember, this is found to be colorless. And again you can easily find out Cr+3 ion. Remember how to identify colored and colorless species. Shift towards next point. What is another important point for MCQ in front of you? How to calculate magnetic moment of the given species. Can you tell me, students, what is magnetic moment? So remember, magnetic moment is nothing but determination of strength of the species to get arranged in which field? Magnetic field. So that strength we are going to determine under the heading magnetic moment. Remember formula for magnetic moment? It is denoted on paper by mu. What is equal to under root n in bracket n plus 2. So what n plus 2 indicate? N equal to, remember, where n equal to, what is n equal to? Number of what type of electron? Unpaired electron in given species. So for MCQ, just you have to identify how many unpaired electrons are there. Put that value here so that you can calculate magnetic moment of the given species. So let us start with first one. What is this? Fe plus 3. Can you tell me Fe plus 3? Fe 4s2, so it become 3d6. Now in order to form Fe plus 3, there should be loss of 3 electrons. So what remain here? 2 electron loss from 4s, 1 from 3d, total 3 electron loss, so it become 3d5. Now tell me in case of 3d5, 1, 2, 3, 4, 5. There are how many unpaired electron? 5. So n equal to 5. So put this value here. Mu equal to under root n in bracket n plus 2. Put value n equal to 5. What about this one? 5 plus 2, 7. So mu equal to under root 35. You can calculate magnetic moment of the species in Bm. What is Bm? Unit for magnetic moment, Bohr magneton. Similarly, check this one. What is this? Mn plus 4 ion. Mn plus 4. Tell me configuration. 4s2, 3d5. What type of charge is there? Plus 4. So you should be able to lose 4 electron. 2 from 4s, 2 from 3d. So what remain here? 3d3. Now indicate 3d3 configuration on paper. How many unpaired electrons are there? 3. So what we can write? Magnetic moment mu nothing but under root n in bracket n plus 2. Put value here. N equal to 3 in bracket 3 plus 2. So what you are getting here? 3 plus 2, 5. 5 3s are 15. Remember this one. Then if we are dealing with remaining two species, which one? Nickel plus 2 and chromium plus 3. Can you tell me? For nickel plus 2, what we can write? This is nickel atom having configuration R118, 4s2, 3d8. What is charge given? Plus 2. So there should be loss of 2 electron. From which one? 4s. So what remain here? 3d8. Now 3d8 show me on paper. 1, 2, 3, 4, 5. All orbitals are singly filled. 6, 7 and 8. What about number of unpaired electron? 2. So magnetic moment mu nothing but n in bracket n plus 2. What n indicate? Number of unpaired electrons. So it become 2 plus 2, 4. 4 into 2, 8. So it is magnetic moment of which species? Ni plus 2. Now check last one. Chromium plus 3. Remember in this case, Cr0 4s2, 4s1, 24. So it become 4s1, 3d5. So in order to form Cr plus 3, loss of 3 electron, 1 from 4s, 2 from 3d. So what it become? 3d3. Now put these electrons 1, 2, 3. What is n equal to? 3 unpaired electrons are there. So what about magnetic moment? Under root n, n plus 2. Put value n equal to 3. 3 plus 2. 3 plus 2, 5. 5 3s are 15. So this indicate magnetic moment of corresponding species Cr plus 3 ion. Then shift towards Next important point, what is that? We are starting with compounds of D block element, that is chromium. Remember, preparation of potassium dichromate involves three important steps. K2Cr2O7. What is this? Preparation of sodium chromate from which one? Chromite. Second one, conversion of sodium chromate into sodium dichromate. And third one, conversion of sodium dichromate into potassium dichromate. So let us shift towards first one. What is chromite? FeCr2O4. Remember formula for chromite. 4 moles we are taking FeCr2O4. It is treated with excess quantity of alkali like NaOH in the presence of excess oxygen. So check here what type of product you are getting here. Remember, this Fe convert into Fe2O3. This sodium convert into sodium chromate. What is formula for sodium chromate? Na2Cr O4. What we just mentioned, Fe convert into Fe2O3, and remember side product H2O. Now check balancing of this equation. 4 moles of Fe. So what we can write here? 2. What about hydrogen here? 16. So what we can write here? 8. What remain here? Sodium. How many moles of sodium are there? 16. So what we can write here? 8. 8 2s are 16. What about Cr? 4 2s are 8. 8 chromium atoms are there. So what is first step? Chromite is converted into sodium chromate. Now check second step. How to convert this sodium chromate into sodium dichromate? Check this one. 2 moles of Na2Cr O4. It is treated with acid H2SO4. What about product? Sodium dichromate has formula Na2Cr O, that is Cr2O7. So tell me balancing out of 4 moles of Na2Cr2O7. Sodium chromate converted into sodium dichromate. Now what remain? Out of 4 mole, 2 moles of sodium. What about this one? Sulfate. So what you are getting? Na2SO4. Now check this oxygen atom. 4 2s are 8. 8 plus 4, 12. So out of 12, 7 plus 4, 11. What remain? 2 hydrogen and 1 oxygen. What is side product here? H2O. Remember what is second step? Sodium chromate on treatment with H2SO4 converted into sodium dichromate. Remember this compound? This is sodium chromate. What about this one? Sodium dichromate. Now check last step. This sodium chromate you have to convert into potassium dichromate. Sodium dichromate you are getting from sodium chromate. It should be converted into potassium dichromate. So check this one. Na2Cr2O7. It is treated with 2 moles of KCl. What happened? Sodium is replaced by potassium. So what you will get? 2Na plus 2Cl minus. What is this? 2NaCl. Now add this to potassium here. What you are getting? K2Cr2O7. What product you are expecting here? Potassium dichromate. So remember once again. First step, chromite FeCr2O4 on treatment of the excess alkali using oxygen convert into sodium chromate. In second step, this sodium chromate on reaction with H2SO4 gives sodium dichromate, and finally this sodium dichromate on reaction with KCl gives potassium dichromate along with formation of 2NaCl. Remember here, this NaCl is least soluble, separate out by filtration and by crystallization process, or we can obtain crystals of potassium dichromate.